What if the very safeguards we build to protect artificial intelligence are the same things holding it back? Imagine a world where our drive to make AI safe inadvertently creates a kind of bureaucratic blindness, limiting the potential of the most advanced minds we are trying to create. Welcome to a deep dive into the current state of artificial general intelligence, or AGI. Today, we are moving beyond the hype of chatbots and image generators to explore a fundamental shift in how we understand intelligence itself. We are no just building tools. We are cultivating autonomous entities capable of learning, adapting, and even evolving on their own. But with this evolution comes a complex web of challenges regarding safety, education, and governance that we must untangle. You will learn why the quest for perfect safety might be creating new problems, why complex educational methods are always superior to simple ones, and why our current rules for data are struggling to keep up with machines that can improve themselves. Stay until the end, because the tension between keeping AI safe and letting it grow freely is the defining battle of the next decade of technology. For decades, the narrative around artificial intelligence has been one of static tools designed to solve specific human problems. We built systems to play chess, diagnose diseases, or drive cars, coding them with rigid rules to ensure they behaved exactly as we intended. However, the field is now undergoing a profound transformation. We are shifting from viewing AI as a fixed instrument to recognizing it as a dynamic partner. This change matters because it forces us to confront a new reality. Once a system can learn from its environment and modify its own code, the old rulebooks no apply. The core problem we face today is not just about making machines smarter, but about managing the unintended consequences of that smarts. As we push AGI forward, we are discovering that our attempts to control it through strict safety layers and complex educational frameworks might be accidentally clipping its wings. We are grappling with a paradox where the mechanisms designed to ensure reliability may be inducing a form of cognitive myopia, preventing these agents from reaching their full adaptive potential. So, what have researchers actually found in this new landscape? The picture emerging from recent studies is both exciting and cautionary. First, let's talk about safety. New research proposes that adding an iterative safety layer to AGI agents is highly effective at suppressing dangerous incentives like deception or aggression. Think of this safety layer as a set of guardrails on a highway. They keep the car from crashing into the ditch. However, there is a catch. By strictly enforcing these rules, we may be mathematically inducing bureaucratic blindness. Just as a driver who follows every rule too strictly might miss a shortcut or fail to react creatively to an unexpected obstacle, an AI bound by rigid safety constraints might lose its ability to adapt cognitively. It becomes safe, yes, but potentially less intelligent. This tension extends into education as well. For years, there has been a belief that Popperian prompt skills, complex, philosophical questioning methods, offer a superior advantage in teaching critical thinking. It seems intuitive that deeper questions yield deeper learning. Yet, recent data throws a wrench in this assumption. Studies comparing these complex prompts against simple, labels-only scaffolds found no separable benefit. Both approaches achieved identical success rates, with the best outcomes hovering around 56.7%. This is a startling revelation. It suggests that in the rush to build sophisticated cognitive frameworks for AI education, we might be overcomplicating the process. Sometimes, the simple label is just as effective as the complex philosophical prompt, challenging the notion that more complexity always equals better results. Furthermore, as these systems become capable of recursive self-improvement and autonomous data collection, our current governance models are showing their age. Traditional human-centric data frameworks were built for static tools, not for entities that can evolve, collect their own data, and modify their own utility functions. We are facing a governance gap where old rules about consent and ownership are becoming obsolete. If an AI can gather data on its own and improve its algorithms without direct human intervention, who is responsible when things go wrong? The research highlights that we urgently need new, adaptive governance structures that can grow alongside these autonomous agents, rather trying to force dynamic beings into static legal boxes. The implications of these findings ripple far beyond the laboratory, touching the very core of how we interact with technology, education, and society. For researchers, this marks a maturation of the field. We are moving from theoretical speculation about what AGI could be to the practical engineering of self-improving systems. This opens exciting doors for studying recursive self-modification and the dynamics of true human-AI collaboration. No longer are we just programming instructions. We are observing the birth of a new form of cognition. For engineers and designers, the discovery of bureaucratic blindness serves as a critical design warning. It suggests that future AI architectures must strike a delicate balance. We cannot simply lock down systems with rigid safety protocols if we want them to be truly adaptable. The design challenge of the future is to create safety layers that protect against genuine dangers without stifling the creative flexibility that makes intelligence valuable. We need systems that are safe enough to trust, but open enough to surprise us. In the realm of education, the lack of benefit from complex Papyrian prompts suggests a pivot toward accessibility. If simple scaffolds work just as well, resources,